Hello, everybody. Sorry I'm late. I had some computer troubles. I'm not a wizard, Mark Olson. I am just a guy. How's everyone doing? Hope you're doing okay. So yeah, as the title of the video suggests, we've got a new IC to try out for the TS100. But also the parts arrived for the design we did the last time. Let me just fix that for you. Total Pro, doing it on stream. Focus. Yes, so the parts arrived for this design. Yes. Praise Crowley. You're a day early to praise Crowley. Or maybe Crowley migrated north for the Australian winter. Hello, everybody. Okay, yeah, so here is our IP2721 design. So if you were here maybe 3 weeks ago, we designed this, and this is it in the flesh. It looks like it'll be really difficult to hand solder. Yeah, let me try get you a little bit more focused. Like, they're quite close to each other. The legs of the IC and that, kind of similar for the resistors. They're also 0402, which are so small. Like, I don't know how to even show you how small they are. This is a USB-C connector. It fits a lot of them. So, yes, this is what we affectionately call the fire starter. And when we assemble this up, maybe we'll show for the first time what problem it has. Because since the last time I was talking to you, I bought a lot of USB-C power supplies, all with different power ratings. So I have my power bank one here. This is a 60 watt. So I've been using that to power my TS100 before. I'm after getting a 30 watt one here from Amazon. This is actually a really problematic charger because it does 20 volts. It's not enough amps. And then I also got this U-Green charger, which is an 18 watt one. But the max this does is 12 volts, so this actually works fine. Or at least should work fine. So I am going to try use paste and hot air to assemble this. My paste used by August 18, so it's real good stuff. I don't have anything newer than that, so we are where we are, and we'll see how we get on. Possibly terribly. I have enough stuff to do a couple of tries, so we'll see. Ireland does use the same plug as the UK. Yeah, from a building point of view, we use a lot of the same stuff as the UK. Okay, so let's, the other thing then we have is this ST USB 4500 reference board. So this is another power delivery IC, and it's programmable via I2C. So there's some pads at the bottom here that will solder some connections to, and you can upload profiles to it. So yeah, like you'll be able to say, hey, if this charger can't do 20 volts, 2.45 amps, or whatever the requirement is, that 20 volts is off the table. That's the problem with the IP2721. It just says, give me 20 volts. It doesn't say anything about current. So, yes. Hello, Ray. Hello, Dren. Hello, Gavin. Hello, Adam. Mark, Aaron, Andy, and everybody else in the chat that I haven't said hi to. Hello to you. Alright, so because my paste is so old, the first thing I'm going to do is put some flux down. I do have some of the gooier flux, but I'm just going to try the pen flux because that's what I normally use. So I'm just going to apply a nice amount of flux all over the place. That might be a little bit too much. Oh no. You get email notifications from YouTube. I don't. I just get push notifications sometimes when people go live or whatever. Never email. Okay, I'm gonna have to move you up a little bit. See, this is the problem of not having a microscope and just using a webcam, is that the distance between like where the webcam is and the desk is, you know, it's not that big. It's maybe 6 inches. Yeah, so we'll see how we get on. I think for the IC, I'm just gonna have to mash it across. Like I'll never be able to just put a bit down anywhere. Who's Emma? I just see someone saying hi Emma, and I don't see any Emmas. I don't get any notifications. Yes, that is also similar. Okay, so I'm just going to put a layer of this down. Just by the way, where am I? There I am. Just by the way, I am not, oh yes, hello Emma. I am not the person to like base your solder paste application or anything on. I don't know what I'm doing. Oh, there's lots of Emmas, significant other Emmas. Hello to Mark's Emma too. So yeah, don't copy this. Okay, so time to apply some paste. Hello, Death Shaker. I'm doing anything but trying to do this. Okay. It's not exactly it's not exactly coming out of the thing too easily. Here we go. Well, that didn't go quite to plan. It's not. Maybe me applying flux at the start was a bad idea. It's not really sticking to anything. I'm currently making it worse as well. Come on, stick down. Hopefully Sion's still in bed. I did apply some flux. It's just not the gooey flux. You can see the shininess of it. Even if I got... Oh, sure, look, let's just see how we get on, huh? I'd nearly do the IC first, so I can touch up. Come on, break off. Break off. That went a little bit better. Will we do the IC first? That mightn't be a bad idea. Try blue tack for the board. The tool in my left hand. Oh, this tool. Yeah, my solder paste is like almost 3 years out of date, or 2 years out of date. So will we throw an IC on it and see how we get on? Oh, I know there's enough. I'd say there's too much. Yeah, because the middle one is the biggest problem. So I should have bought a stencil for this, but I forgot because I don't normally buy stencils because I don't normally do that is a USB-C footprint. It's a power only USB-C footprint. So it should be a little bit easier to solder. Okay. Ooh, I've got the shakes. Good. That's exactly what you need when you're placing components. Just really isn't sitting at all. Like the paste is just staying as a solid mass. Okay. Right, I'm gonna turn down my air a bit. My heat is at, I'll try 300. So I'll just see how we get on. It just has turned to a big pool of solder. I got my tweezers and my... Oh, well, there, it turned into a big ball of solder now. I definitely should have the board attached down, so forgive me for that part of it. Okay, it seems to have surface tensioned itself. Oh, sorry. It seems to have surface tensioned itself into the correct spot. I just have a huge bridge on either side. That is not going to go away with applying more heat. So I guess it's time to... it is time to take out the braid or something. Or solder wick, not braid. Is it wick? Braid? Where's my wick? Okay, be right back. found my solder wick. Just going to apply a little bit of flux on it to help us on our way. Suppose I need my soldering iron. To try suck this out of her. You're shocked. County Wicklow. You're shocked that there's no storage racks. Yes. Well, the reason that there isn't any yet is this should be the master bedroom. Sorry for making you crap. I have two wires here and I don't know which one is which. This doesn't seem to be it. Is this it? Yes. This should be the master bedroom, but I'm here for sound reasons until we do some insulation. Sound insulation. And yeah, I'm not going to do up this room a massive amount into my office while we will be. Sian, if you could just like come back in like half an hour, that'd be great, because you're not gonna like what you see. I wouldn't think. But good morning to you too. Let's try to get some of this wick going. Come up. That's still pretty hideous. I've got the shakes. Again. So supply a bit more flux to the party. Just that pen is an aggressive applicator. Getting there. Getting there. I had so much excess stuff I nearly could have used like the pump or something, but we're getting there. I need to attach down this board. Although it's not really going to attach to it's not going to attach to cork well. The blue tack. Maybe even if I just kind of put almost rubber feet on it with the blue tack, it won't move around as much. Yeah, I've been putting a little bit of flux on the wick, and I do find it helps as well. I'm not very good at using wick, which I don't know if that even makes sense, but so not only would I not copy me for reflowing purposes, I wouldn't copy me for wick purposes either. We're nearly there though, I think. Just have one left to do. Find a nice clean spot on our wick. Give it a go. There we go. It's very shiny, so I'll try get a decent. Hey, Gerald. This is the IP2721. It's a Chinese IC power delivery chip. So I don't know if you can see that. I really have the shakes today. But that looks okay to me. Looks alright. That side, not so much. We have to... I think I might actually use the... I'd be tempted to use the pump on this side. There's that much excess stuff. Like, rather than wicking it. But I don't know, the wick worked well, so... You can flux and draw from the chip. Yeah, that might be an idea too. We'll give that a go. I've had success with that in the past. So what you want to do with that is put your flux down, make sure your tip is pretty clear. I should do that, Sion, I just missed your thing. So what Sion is referring to there is the fact that I have a reflow master and a toaster oven. Oh, what happened here? Oh, I zoomed you in. I have a reflow master and a toaster oven. I think the problem... What is going on here? Focus. I think the problem would still exist because I forgot to buy a stencil. That worked pretty good, I think. No, it's just might just cut off some of this wick. Yeah, so I have a toaster oven. I have a reflow master. Those two things are not connected together yet. But I also, because I didn't have a stencil, I think whatever my reflowing method was would still be absolutely garbage. Hey Pete, things are going pretty good. Thank you. Hey, that looks alright. I think that's done. Looks alright. Yeah, I haven't released a video in a long time. What brand wick am I using? This brand? It's some cheap AliExpress stuff. This I really like. I've been thinking about doing like a video series of like, is it worth it, basically? Like, there's been some things that I've bought where I've like went and got a better quality of something. For example, like this, you can buy solder suckers from AliExpress for like what, $2, maybe $3. This was like £20, and this is amazing. Like, it feels like a spaceship compared to the other things. Like, it's very nice. The nice little silicone top. It's small. It just feels great. But like, yeah, there's a couple of times I've done stuff like that, and it's like, is it worth it or not? This is end of video. How do I turn that into a video though? Maybe if I group a couple of things together at a time. I am Groot. I've never seen Guardians of the Galaxy. I've seen very little Marvel movies. Yeah, I have unleaded solder here, but I mainly use leaded solder. I'm not even 100% sure why. Okay, what will we move on to next? The 0402 stuff? I suppose I could do nearly all the stuff now. Give it a go. Right, I'm just going to use the same will I use the same string? I don't know. Let's get my paste flowing again. Okay, we're flowing. I don't know if the fact that I'm doing it at an angle is also causing problems. My shaky hand is definitely causing problems, and I don't know where that's coming from. I've normally not this shaky. I suppose I could spray out a little bit with flux, mix it up, and maybe it'd be a bit more pliable. Yeah, do I have a toothpick? I must have a toothpick. Hey, Pete. Yeah, so the TS80. So, the TS80. I'm just gonna spray a little bit out here, and this is like the shiny bit of like a sticker. The TS80 uses something called QC power, and it's not that common. Like most high current USB-C things use power delivery, which the TS80 doesn't support. And that is what I will be adding to this here now, is power delivery. Or sorry, this is what this IC does, is power delivery. But quite recently, just in the last few weeks, the makers of the TS80 and the TS100 have released a new board, or a new soldering iron called the TS80P. I think I used too much solder paste, or too much flux. The TS80P, and that does support power delivery. So it'll be interesting to see how that gets on. So say, for example, with this board here, I'll be able to power this off my Mac charger. And I have, like this TS100, which I'm using right now, is being powered using basically this IC already. Oh, this is a mess. It does stick a little bit better though. Guys, do not be like me. Look, that'll reflow just fine. Yeah. That's not a toothpick. It's yellow. It's a piece of wire. I don't know where a toothpick is, so I improvised. As I said, do not copy me. whatsoever. Look, this is fine. I can hand solder the bigger cap. Look, Sion, I told you to leave. Yes, Pete. So like this, the majority of power banks that can do like higher voltages would use power delivery as the like standard it uses. So for example, like this is a power bank here, a pretty standard power bank. And like I can power the TS80, or sorry, the TS100 off this power bank. You can't power the TS80 off it because it doesn't support that QC thing, but you will be able to power the TS80P from it. So, look, I'm sorry. Look, I'm sorry. I'm doing my best. By best, I mean I'm doing terribly, and I'm sorry. I'm not even on camera at the moment. Okay. I'm a little bit out of focus. I don't think that's the worst problem in the world. I think it's saving you some nightmares. Bloody shaky hand. Oh, this is not going. This 0402 is not going to come off my tweezers. Let me just try whatever I can off it. Perfect. I don't even know if I'm on the pads anymore. Oh, I'm so sorry to anybody who has to witness this. So I do have IPA. Do I have some form of like vessel that can support putting IPA in it? Doesn't look like. I suppose a plastic thing here might do the trick. My mouth. Wash your mouth out. I would normally try solder. Like I've soldered SMD stuff before, but the 0402 is. I know some people can solder down to that size, but I don't know. I don't think I'm those people. Okay. My tip is clean. So the next thing I found was this MOSFET, P-channel MOSFET. Does this work? Who knows? That looks good. Sort of. What else we need? We need some resistors. The resistors came today, so I know I have them. Spray bottle for IPA. Well, that's a good idea. up on my desk that I didn't realize I had. I should probably try put some things away when I'm finished with them. IPA and tonic. Oh, these are so small. Why did I make them these small? You see, the plan is to have these boards assembled by somebody else. So I'm kind of like, here, make them as small as you want. But I didn't really account for the fact that I'd have to assemble them to test that it worked. Sure, look, it's an experience. That actually, oh sorry, that one went down okay. That one is a little low. That seems okay. Right, back to hot air time. I'm gonna turn down the air a decent amount though, because of the fact that these components are so small. I don't particularly want them blowing away. I'm really hoping this surface tension crack does its job. Yeah, look at that. Woo! Oh yeah. I don't know how that came out on camera, but it looked pretty cool here. I'm pretty sure this pad doesn't have enough stuff on it. I can touch that up with hand solder though. Looks alright to me. Whee! Oh, I think Sion has enough stuff to assemble on his pick and place when he gets it. Pretty sure he's a pretty big backlog of stuff he needs to assemble, so I'll leave Sion's pick and place for Sion. It's quite magic looking, isn't it? To just see it go a little hot. Might have been too hot. I don't know. It was that like 300 or something? I think with the hot air, it's kind of hard to control the airflow anyways, so it's kind of hard to know where you're going with it. The old toothpick trick didn't work out too bad. And by toothpick, I mean not a toothpick at all. My little piece of wire. Okay, so I'm just gonna hand solder the 0805, which looks massive to me at the moment. I'm just going to put a little bit of flux down because it's quite large heat sinks. Well, not heat sinks, but the copper pads that it's attaching to are relatively large. I know it's a small board though. So probably I'll just tin up the iron a bit. My favorite number. Okay. So I'm just gonna go on one pad. Get my maybe tiny bit more. Get my tweezers, which I placed somewhere. Okay, that looks relatively alright to me. Go the other side. Seems alright. Oh, I will happily go back to anything but 0402. But when I'm getting somebody else to assemble it, I will. Or do you know what? Even if I had like proper solder paste and a stencil, wouldn't that be something? Okay, so the last thing I need to do is the USB-C pads. They're quite big. I feel like I could probably hand solder them, but I'm going to use the paste and flux method that we used already. It worked out pretty well, so why mess with success? So I'm just going to put a small amount of flux down on my special flux applicator. I still swear by, yeah, the bigger the better. I find 0805 absolutely fine to solder. Like, I have no problem with 0805 at all. Come on. Okay, let's see how we get on. Get our special flux and solder paste mixer. It seems to have very stuck together. But this is special paper that you can bend like that, so it's all good. I haven't drank coffee since 2017, so I don't think so. Need a little bit more on it than that. I'm tempted to just kind of like wipe across it. I did drink decaf today, which is not unusual for me. But it was new decaf, so maybe they just sent me regular stuff and I'm jittery. But I haven't drank it in hours, so... Ugh, look, let's just spread it across like this. Should I just clean this up and start again? Do you think it'll fix itself? This is hideous. I haven't drank since 55 minutes ago. I'll tidy up back here a little bit because we can't see what's going on there. I think the other thing will be alright. Front will be fine. I used to love coffee. It was my favorite drink, but I stopped drinking it for anxiety reasons. I used to, yeah, it does have caffeine and it's just less, but yeah, I used to drink too much coffee to make up for the fact that I didn't sleep enough, and it was making me quite anxious, so I stopped. Drinking coffee. Okay, we will get our I don't have a great angle for you here, sorry. Because the shadow of the USB-C connector is kind of causing problems. Movie here. Come on, go. Here we go. Okay, there's a couple of bridges. Maybe I'll just tidy it up a small bit. So, Mr. Soldering Iron, get back in the game. Right, let's cut ourselves a fresh piece of wick. Where I put my cutter, I don't know. Matcha tea, interesting. Excuse me. I hate soldering USB connectors too, but this is entirely on me because these are quite spread apart. Like I feel like you could hand solder this relatively easily. I've made a couple of Jeff bridges on the PCB. I sure have. So I don't know if it's too visible to you, but the left two are fine. Then the next two are bridged, and then the next two are bridged. So let's get rid of these Jeff bridges, as you call them. And there we go. Jeff bridges fixed. I guess we're in a position to test it. I am not going to plug it into my TS100 first. It's whiskey. I don't drink either. Do I have a source part number for the USB-C? I do. I do. So if you go to my Hackaday page, I'm just going to share a link with you guys. So I'm starting to, I'm going to be writing this project up on Hackaday. Hackaday IO, because I feel like that's a good position for, or a good place for this kind of a project where I'm still kind of actively working on it or whatever. So included in that is a link to the EasyEDA project for this. This is going to be an open source project. And yeah, if you look at that Hackaday page, there'll be a link to the EasyEDA IP2721 version. And this is it. What you see there is that project. Right, so the first thing I'm just going to check here is there a short between power and ground? My high quality multimeter. Okay, no short between power and ground. So that seems good. I'm gonna plug in the worst charger that I have, that it can draw 20 volts. So if it blows up, it is the worst charger that I have that blows up. So, okay. What do we think? Where did I find the IP2721? I found it as a module on AliExpress, but where did I source them? I got them from MakerFabs. MakerFabs are assembling some power blockers for me, and I asked could they source me some of these, and they said yes. So that's where we got that from. Okay, so before we plug it in, what do people think? Is it gonna work? Not gonna work? Sorry about the me in the way. Making number one right now. So what do we think? It's gonna work? Not work? Taking bets in the chat, but not real bets, because I don't really gamble. What do we think? 100% Rory McLeod. It could be 100% yes or no. It will work. It would work or that. Or not. That is the question. Time to go. Bye all. Solder my USB grounds. Oh yes, good point. I don't have my shield soldered, so I'll do that. Don't go that far in. Is that typical? Put a little bit of flux there too. No. See, Adam. Magic smoke. Element 14 is the chip. Oh, that's useful to know. Is it expensive? It was pretty cheap off MakerFabs. Mic is in a bad place. Hey Ansh, I don't think you'll learn too much on this stream though, but definitely won't learn how to solder. That's for sure. Shaky bloody hands. The fact that the board is not attached down is also a disaster. There. No. Looks alright to me. It's alright. I'm nervous. It's my first day. It's not like I've streamed semi-regularly for like 2 years. I know I took a fairly large hiatus, but I'm trying to make my face less bright, but I think we are where we are. Okay, not checked the price yet. Yeah, I think it was like 60 cents or something off MakerFabs in low quantities, so yeah, okay. Let me get out of your light so you can see the magic smoke if it happens. Okay, so this should... Oh, I should have got a stencil. I forgot. You see, I don't buy SMD boards all that much. I make my... yeah, I do have a pretty pale face. But, yeah. Okay, so this, if it worked, should be outputting 20 volts. It is not. It's outputting 5. So it's outputting 5 volts, not 20. So I guess we need to figure out why that is. So maybe if I just plug it back in again. 5 volts is like the default state if it failed to negotiate anything, as far as I know, so it's staying at that. Maybe I'll try. Does it ever? No, it stays at 5. Okay. Ooh, yes, the FET pin. Yes, I was a bit worried about one of the FET pins, wasn't I? Oh, the FET pins look very bad, actually. So only one of them looks decently soldered. So let's fix them. So this one up here under my hand looks terrible, and the one on the left doesn't look much better. So let's throw a drop of solder onto them. Okay. Again, not terribly good soldering, but should probably do. And I have a USB solder thingy. Okay. Now it still is only doing 5 volts. Or did I do something wrong with it? Easy EDA. Return the USB. It must be the USB cable's fault. Let's open this project. I have to log in. The other thing as well is, okay, this doesn't work. Do I bother fix it? You know what I mean? Like, I'm almost certainly not going to be using this. It would be nice to know what I'm doing wrong. The IC is not hot. Nothing is hot on the board. Selection pin is pin 11. I don't think putting a load on it would do anything. So I'll plug out the TS80 or TS80, TS100. Sorry. So this is the same IC, but on a module rather than on my board. No load, and it negotiated 20, so I don't think that's the problem. It looks soldered fine, the IC. I don't see anything being a problem with that. The resistors aren't great, but I don't know. Could reflow them. One of the USB-C pins looks a little bit dry. The two on the left don't look great. So I'm just trying to get the focus thing up here. The IP2721 doesn't have I2C. You see that pin there? That doesn't look great, does it? What is that pin? That's a VCC pin, so probably doesn't matter. Seeing as it has the other one, but we'll try fix it all the same. Pin 11. Hot early IC off and on. Let me just check. Yeah, sure. VCC has to be only 5 volts because I'm checking it before it goes in. Hello, Photochromax. They mightn't be on okay. I'm not 100% convinced on them. I might try get them to flow first. I'm not super happy with them, so I might try them first. Apparently I've learned nothing from the last hour of doing this. It's so shiny. Hot air them off and on again. Okay, let's do that. I'm just gonna clear a bit of mess out of my way first. Looks a bit better. Yeah, looks a decent about better. Still have a huge amount of excess solder, but that should be okay. Maybe I'll just wick it up a tiny bit to make it put the resistor the wrong way around. Could have. I'm sorry about the shiny light bouncing off the thing. It's kind of hard to I don't know where to put it that I can still see, but also the black solder mask is not I'm gonna wick off a tiny bit of this oh, the USB-C thing is hot. To power my TS100 again. A polarizing filter on my webcam. Can you get polarizing filters for webcams? My big head is in your way. Yeah, they look okay to me. So let's try it again, I suppose. It's weird that it thinks that power is going the opposite direction. Still no bueno. The USB-C, that looks fine, so let's try the... Oh, the ST USB 4500 is the IC that I will more than likely swap to. But this was a design I did a couple of weeks ago, and I said we'd assemble it. I didn't think we'd be this long assembling it, but I still have not learned anything by the looks of things. I'm gonna burn the hand of myself now. Okay. That's it lifted and put back down again. It's a good suggestion too, Unexpected Maker. Actually do some proper debugging. The IC is not that straight anymore. Should probably fix that. Well, way overcompensated. Crap. Ah. Yeah. Let's not cook this any more than it needs to be. Okay, that looks alright. That seems too hot. Turn it down. Oh! Oh. Yes, that is a problem. Okay, is it locked or something? Why can't I move it? It's not letting me move it for some reason. I can move my desk. There we go. I need to see my... This is the IP2721. Okay. Oh no. My overheated blue tack. It's actually very hot, the blue tack. Okay, let's beep out some traces. I'll tidy up that blue tack in a minute. People keep saying my tweezers are posh. They're like from LCSC. They are really no more expensive than any other tweezers. Okay, so CC2 should be this top. If I can straighten up the CC2 should be this thing. It should be connected to this. Then also should be connected to this leg of the IC. And it is. Yeah, CCs are okay. The resistors should be pulled down, I believe. So let's just check that. Oh, interesting. Oh no, there. Okay, resistor is pulled down. Let's make sure I have the right resistance in it. So if I measured between this leg of the AC and ground, $5.1K, which is right. Sorry. Yeah, so the CC stuff looks fine. I suppose I should probably be looking at their data sheet and not my schematic though. So let me just open up that. Documents, data sheets. IP2721. Desk, screen share plus desk. Yep. Right. My select pin, I should check that that's high, I guess. Is the IC the right way around? I'm pretty sure it is. Mightn't be. Pretty sure it is though. But a good suggestion. Do I have some bridges since I reflowed it? I think I do actually. I seem to have some Jeff bridges. Maybe since I reflowed it, maybe since before. Vout is selectable by just putting a pin high floating or ground. You can see it kind of under my face there. That is high floating ground. So that is what Vout stands for. Or that's what makes V out high, low, or indifferent. Just gonna flux. Oh, I suppose I should probably show you what I'm doing. Just gonna flux some of these pins. Well, so I've fluxed them dry, you know. Or sorry, wicked them dry. So I guess I just... we'll try do a bit of kind of drag soldering with them. Which I've executed brutally. This survives this now. Fair play to the chip manufacturer. It is a pretty minimalistic datasheet. Another reason why I'm happy enough to move to the ST USB, because they've got a better datasheet. A lot of these are normally not connected, so... Probably switch to a finer tip, but we are where we are. Let's try to just use the soldering iron itself to wick this away. Okay, we have that tidied up now. I don't know how much of that you can see. Almost none, I would say. But that's tidied up. Let's just check for shorts. Isn't there some kind of resistor or load anymore for these kind of USB-C? I mean, step up boost part is easy. I don't understand what you mean. Ah, look, I wouldn't listen to anyone saying. I know, I totally should, but just checking for shorts. None found so far. Okay, we're short free. Let's check the pin 11. I really need who's the German YouTuber? Is it Bitloony? I hope it's Bitloony. Yeah, it's a really sophisticated protocol that does the negotiation, and this IP2721 does that. Okay, we've made some changes. Something with Scott. Great Scott. Yes, I watched his last video too. Still only 5 volts. I'm missing something. I just have to check the select pin, right? The select, and that it's upside down. I suppose. All right, so the 9, 10, 11. So this is 11. And it should be connected to VCC. And it is. Yeah. Not too sure. I checked the resistance on one of them anyways, and I had the right resistance, but yeah, I can check on both. .1 on that one. 5.1 on that one. Yeah, so I have 5.1 on the 2 CC pins. I don't know, the chip looks soldered. I don't think this is really important either. Check on the chip, no USB. What? Well, the chip mustn't be dead. Yeah, it's 5.1K to ground. The chip mustn't be dead because this isn't on. And I plug this in. And it has it has some form of a load now. Like, as in, it's done something. Which NMOS am I using? I can't remember off the top of my head, but if you go through that the Hackaday link, don't have a scope, so we are no bueno with that. But the only thing, the FET is like, I don't think the FET is overly important to the situation, right? Like, yes, the FET impacts the output, which is obviously a problem. I wonder, am I best off just getting rid of me, maybe? So, like, this is the circuit, right? So the FET controls VCC to V out, right? So V bus G, and controls what goes out on this. There's a link on the Hackaday one for FlexiFriend Easy EDA files. That's a project that has the design and everything. like the schematic would have it. Here it's the, well, maybe I'm just using a random thing. I don't think so. Where is the... I don't know where I put the bag of the FETs. Is it this one? Okay. It's this is the part number. C20917. C20917. Yeah, but I don't, but you see, I'm testing the input, right? So, like, if I removed this FET even, what comes in on VCC is not going to change, right? Like, if the IP2721 successfully negotiated 20 volts, it would be 20 volts here, right? As in, what comes from the charger would be 20 volts. And like, this is where I'm measuring, is at the charger side of it, right? And I'm only getting 5 volts. So, like, it couldn't be the FET. That's the problem, right? Like, the FET would impact the output, for sure. But it wouldn't impact the voltage that it negotiates with the Type C or the power delivery board. Like, it's outputting the same as the input. The FET, what the FET should do is it should block it from outputting to the output. I'm pretty sure. Yeah, the FET should block it outputting to the output unless it's successfully negotiated power delivery or a power delivery profile. Yeah, that's why I'm pretty sure that this works okay, because this is the same IC, just with on a module from so like that's negotiating 20 volts and it's okay. The arrow is opposite, but I guess if there's no load or not a significant load, it doesn't know what to do. So there's the arrow going in the correct direction. It's funny actually that it's not letting me power up. Oh, do you know what it is actually? This is a perfect test. I'm trying to power this from an underpowered power supply. So it's connected to a 30 watt power supply, and this needs at least like 46 watts. So when I turn on the TS100, it's over current protecting and just dying. And that's why I want to move away from this chip. Like, it's such a simple design. Like, I can't. No, because I'm running the exact same test with the module, and it's, working okay. So I don't think that's the case. I guess one thing that would be worth checking is what their select pin is pulled up to. So, or what select pin is connected to. So it should be VCC. It's 100K to SELP. Yeah, to select, well, I don't have 100K. I just have it directly connected, so maybe that's not great, but it shouldn't cause a problem. It would explain the extra resistor that they have on the board. 100K. Oh, there was a lot of heat on the IC for sure. Yeah, it could be fried. Let's see what's this connected to. So it's not directly connected to positive. What I think is the select pin. So that's interesting. Yeah, they have a 100 kilo ohm resistor. Yeah, so what I was going by was this says like VCC or something. Let me. You're saying on page 5. Let me just translate it. Just me for a second. Google Translate. Document. I've translated this lots and lots of times. That's okay. Yeah, so high level, that's what I was going by, screen share. High level, 20 volts. You're saying on page 5, it says... select default voltage. This is it here, select pin. Yeah, so when maximum voltage supported is less than, yeah. Where did you see the 100K thing? And where do you see cell P? I only see a cell. Yeah, select is high. So I've select connected directly to VCC at the moment. Search for 100. Okay, so cell. Okay, so that's probably what I've wrong. So, the trace for this is underneath the. It's underneath the IC as well. We're gone this far. Will we just will we take the IC off, cut the trace, and see how we get on? That's just me. This IC has seen some shit. Do I even have a knife up here? Right, I need to check what's underneath that. Yeah. I'll cut the trace. Right, there's very little underneath the PCB. I have another IC, so we can... There's very little under the thing, so I'll just cut, like, up here. If I have a knife. I don't think I have a knife up here. I do have some form of knife. Chip might already be toast. Yep, it might be. Black solder mask. It's so hard to see. That should probably do it. I can put a new IC on it. If we think that would help. Okay, they're no... Oh. They are no longer connected. I suppose it would help if I didn't show you a single thing I was doing there. Yeah, so I cut, you can see the line I cut there. I'm just testing to see if that's disconnected now, so it should be connected to this and this. Okay, still connected. So we need to keep digging. Why am I not just lifting the legs of the IC? Have you seen the IC? It's pretty small. You see, I suppose I could have lifted the legs of the IC. Okay, definitely disconnected now. Okay, we're good. It's enormous. I don't think I'd have the dexterity to lift just one leg of that IC. Like, would you think that? Would you think that lifting an IC is leg of an IC is easier than cutting the trace? Think like a dog, lift the leg. I have a male dog who doesn't lift his leg. He still pees like a puppy. I don't think lifting a leg of an IC is easier than cutting the trace. Like I have mentioned many times, I should not be like someone to base anything off, but I don't know, it just doesn't seem like it would be. Like, especially because the trace was so like isolated as well, in terms of like there was nothing around it, so I wasn't like overly worried about causing any damage to it or anything. Need to oh, something is on the bottom of my IC. Is it part of my cork mat or something? Yep. This cork mat has seen some shit too, by the looks of things. Oh, my IPA that I poured into that little tub is gone. Okay, flux first. There, are you all happy? Guys, I don't know, do you think I should flux it? The IC was the right way around and continues to be the right way around. I hope. I think I need to get my IPA back out again. Let's put this into position. Definitely pouring some more IPA out. The dog drank the IPA. And he's now gonna pee sitting down like a puppy. Flux is my friend. I just poured some IPA in my hands. I'm sure that's great for them. My tweezers are very sticky. Okay. Let's give them a little bit more IPA. People are always giving me crap about my tweezers. Get the soldering iron to them. Ah, guys, where's your sense of adventure? We'll just it actually was pretty good there, and then I moved it. And also, hello David Watts. Poor dog. Oh, it's really not straight. Okay. Are they grooming tweezers? No, they're just tweezers from LCSC that everybody makes fun of me because they're gold. Saying they're fancy tweezers. They aren't even that expensive. I think that looks okay. Oh, that's very hot. Aaron, you haven't missed much. Snobby tweezers. They're not snobby, they're just tweezers. They're just regular old tweezers. No, I'm not convinced that this is... everything's connected here. Okay. Let's see how we get on. It's still bloody warm, but let's plug it in. Still 5 volts. IC must be bad. Oh no. Ouch. I don't know. Is there any point keep going with this thing? We could just go for this thing. And actually, because this is almost a dead project. The problem with this is this power supply. Alright. So this power supply does 20 volts, but it does not do enough amps to support the TS100. While the other cheap power supply, the U green one, it's just floating, so it should be doing 15 volts at the moment. There is no cell P pin, right? If there's a cell P pin, I don't know about it. Celp. I do not see a cell P pin in the entire datasheet. Like, as in, if I search for celp, it doesn't show up. Pin 6. Not the translated version. Okay, so like, it's not in this. Do you have a different data sheet than me? Pin 6. I see pin 6 as TST1. Which I do not have connected to anything. Would I like Edge as my default browser? No. Pins reserved, floating. Can you share? Yes. Well, you can't share your screen, but you can send me a link. I should have made you... Yeah, you're a moderator now, so you should try add it again. I don't need to put a load on it because, well, I guess it could be a different IC now, but the old version of it didn't need load. I still don't see anything, Pete, unless you're sending it to me somewhere else. not working. Yeah, that's weird. So maybe there's a new one. IP2721 datasheet. Did you maybe use this one? Opening up random datasheets. Aha. This is a completely different datasheet than the one I have. What does SELP P do? I bet it reserves, like, current or something? Okay, let's download this one. I'm just gonna stop sharing my screen for a second. Okay, so sure. Yes, IP datasheet 2. Okay, so I'm after downloading that one. Now let's go to Google Translate again. Documents, browse my computer. Okay, just that's plus me. No, screen share. Okay, so SELP P. Well, it needs to be left floating. It's only valid for the IP2721D. IP2721, it needs to be left floating, so it is left floating. What's this IP2721D though? I guess it is worth trying a different IC. Okay, so the D seems to do both. So there used to be an IP2721 and an IP2721 Max 12, and now there seems to be an IP2721 dual, maybe. So I think this SELP. So I have an IP2721, so it doesn't really matter. Yeah, it's definitely IP2721. I could replace the IC with a different one. I could have broken it before this. It's possible. ST USB 4500. Well, it's floating now because of the cut trace. So it doesn't need the 100K. The design needs the 100K, but this board doesn't. It should negotiate 15 volts now. Just gonna move you up a little bit. It's a little bit blurry, but yeah, SELP P is floating at the moment. On pin 6, which is not SELP P for me. Okay. Let me just fix the zoom and focus. But we've tested that it doesn't need a load by using the other module. Like the module from AliExpress is using the same chip and it doesn't need a minimum load. It just negotiates the correct thing straight away. So I don't think it needs a minimum load. I'm just getting a fresh one of these, one that I haven't absolutely destroyed. Before Cyan gives out to me, I'm going to put some flux down. I am going to... Where is it? I'm going to take the advice and solder one leg down. Although, will I be able to do that? I'll do it. I don't think there's much point removing the AliExpress chip and putting it on my board, is it? Like, if these ones don't work the way I want them to, like, this is my source of them, so... I don't think I have enough solder. I definitely don't have enough solder. I wish I had more right now. Just gonna put some on my iron. Oh, it's pretty bad. Come on. There. Okay. I think I have multi-core solder. Well, I've resin core solder. Rosin core? Come on, little buddy. Reflow. Flow and be free. Okay. I had flux down on it. I definitely put flux down on it. Flux. It's not the straightest, but it looks like it's okay. Okay. The moment of truth. It didn't do anything. Ow. I'm guessing it's not soldered up properly. It doesn't look great this side, so maybe I'll hand solder it. Nice bit of bridge going on there. More bridges. Fox down. Suck up these bridges with the soldering iron if we can. Yeah, felt like we got it off there, but then I put it back on. Right, wick it is. A lovely fresh IC is getting ruined. Oh no, we didn't do any of that. We're still making the defunct V1 of the chip. Crap. Okay. Definitely a few more that aren't soldered there. I nearly bought a microscope last year and I'm regretting it. I am regretting it. Okay, let's just... Feck it. I was like, that worked out well. Then I bridged the last bit. No, fixed. It's the other side. The other side doesn't look great either. Yeah, I think most people fairly swear by the strange parts one. Fecker. Ouch. Okay, just one little last bridge to get. The camera with the 100mm lens to the monitor. Yeah, maybe. of people really like the stereoscopic view though through the eyepieces. You can get the module board for $2 delivered, but it won't have the TS100 aspect to it. There. Okay. Look, we're learning so much. Oh, after doing reworking, I have this thing plugged out. Whoops. Aha. Ha 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 ha. So we have 15 volts. So that seems to be the issue. That I should have an 100k resistor between the select pin and VCC. So I need 100k. Will we add an 100k? I'd only have a true hole 100k, maybe a 0805, which are all. It's not going to fit on the board, so it doesn't really matter if it's true hole or 0805 or what it is. We add it? I think we should add it. We're this far with it. Okay, I'll be back in a second. ESD is a myth. It's not really, but I do not have one. Okay, so I have my true hole resistor. I think I'll just not even snip the leg. Let's go for super awkward. Solder it directly. I'll put a little bit of solder on the. Oh yeah, I know. Like, listen, obviously ESD is a potential problem, but I think I'll be okay for now. Come on. Too much solder on it. That looks pretty good. Yeah, that's alright. I don't know if it shows up great on the camera, but it's looks done to me. I'm just worried about bending it. I think this this leg of the MOSFET is probably as good a place as any to grab my VCC from. Well, melt. Sugar lumps. Probably should have done the physically stronger one first. It's not bending. Come on, harden up. Okay. Still happy enough with the other connection. Okay. What do we think? 20 volts? 20 volts, way. Okay, so that's the issue. We may as well, now that we're this far, we may as well actually power the TS100 from it, right? Yes, thank you, Pete, for first time, not first time, or fire time. Yeah, thank you, Pete, for pointing out that there should be 100K. That is obviously a mistake that I made. I should have soldered this before I soldered the super fragile 100K resistor. This doesn't need to be perfect. Do I have? Will it fit down the? Yeah, perfect. No, it was on my data sheet. It just wasn't as clear on my data sheet for sure. So if we do screen share, like this is the new data sheet. Oh, Aaron, thank you so much. Again, wow, thank you, Aaron. This is on the new data sheet, which I can't press Control to zoom in, but yeah, V2, it says it right here that it should be 100K, but on my data sheet, I think it does mention the 100K somewhere, but it doesn't. It's not like front and center about it. Where does it say? Yeah, it's here. So it is mentioned. I just missed it. So, my bad. But that's okay. Look, I don't know if I'm using enough heat or. poor old Mr. Flux has been working absolute overtime. Tonight. Mr. Flux, MVP. I think Sion has probably had to go see a doctor or something after all this horrible reflow work that I've done. But look. Oh, sorry, I'm not showing you anything. Yeah, I think especially as well when you're like translating data sheets and stuff, it just... Now, look, that, again, it's 100% on me, like, as in it's my fault, but I got this 0.6 mil or 0.5 mil solder from this crowd, and I liked it before, but their new one that I got leaves these little stringy bits. It's not nice. I don't know what changed with it, but it's definitely not the same as the first batch I got. Oh yeah, Sion's a wizard. I haven't whatsoever. Right. Yeah. Shit. I forgot that when you use heat to solder something, you might still have some heat left over, and it might burn you. It didn't burn me, it was just hot. No, Graham, you will be here for another while if you choose to be, because so will I. Are you using this thing too, the IP2721 Spectre? Yeah, human pick and place. Okay, so we're gonna... You came just as I got it working, so we figured that there should be a 100k resistor between VCC and the select pin. I just had it connected directly, so I cut a trace and have this this rather comical looking resistor. So just a reminder that this will... I'll swap power supplies actually. VCC is V bus, yes. Well, how do they word them? No, I don't have V. Well, that's weird. They have V bus labeled twice in their data sheet. They have V bus twice in, and they're separate connections. The V bus looks like it's kind of labeled wrong to me. Like automatic zoom. Can I just zoom in like 300%? Like that to me should be labeled V in. Yeah, if you need 15 volts, then floating is good. I'll get it for you, Colin. I might get it after, if that's okay. Would you remind me in my Discord or whatever? I'd be happy to send you the link to it. I also got another one quite recently. It comes in a nice case, but I don't think it's as good. This one here. I bought them like back in January or February, and It only arrived like this week. Maybe it's okay. I think it just needs to flow in a particular direction. Like, I think I'd need to plug this in at my power supply end. Did we work it out? Look at this. Just ignore this 100k resistor. Yes, Sion, we did work it out. There is a 100k resistor that is required between the select and high that I did not have. The select pin was connected to VCC as per this datasheet, which says high there, or more accurately, it says, yeah, high level 20 volts. So I just connected that straight to high level, except down here it says select is connected to VIN through a 100k resistor. I did not have that. So when we cut the trace to the select pin, and it was still negotiating 5 volts. So we were like, well, it should be negotiating 15 volts at the moment, because if it's floating, it should be 15. So we replaced the IC, got 15 volts, and then we added the 100k resistor across VCC and that, and here we are, getting 20 volts. Okay, so here for the first time, let us power a TS100 using this chip. Look at that. Woo! Go, go, go. So you can see it pulls up to about 48 watts. So it should work. Yeah, that's what we think. Probably. Or maybe it was just all the times I reflowed it and stuff. Or it was fairly killed it with heat, like. It probably was from the lack of the 100k. Yeah, so we'll probably fix up this design and maybe order another one of it. But so the problem with this design is, and sorry if you've heard me explain this a few times, but I'll explain it quite quickly. So I have two USB-C power delivery chargers plugged in at the moment. One is a 65 watt or 61 watt charger for my MacBook. This is this one here. And this one is a 30 watt charger. And this one can negotiate 20 volts, but only does 1.5 amps. And as we've seen with this can pull up to like nearly 2.5 amps. I can't Spectre. I bought it off Maker Fabs. I emailed them, like, I was getting other work done with them too, and I asked them, could you source me this chip, and they said yes, and they sent me some. So I don't have a link to it, sorry. Yeah, so this does 20 volts, but only 1.5 amps. And as you've seen here, it needs more than that, the TS100. So if I plug in this, and power it on, it just shuts off. So the power supply is over current protecting. Yeah, so that is, it's breaking Ohm's law. Well, it's not breaking Ohm's law. It's observing Ohm's law, because it's doing the load of the soldering iron is 8.5 ohms, It's at 20 volts, so it needs basically 2.5 amps, and it can't supply that. So it just goes into overcurrent protection on the charger, and that's fine. But like, that charger is capable of powering the TS100, just not at 20 volts. Like, if it was dropped down to 15 volts, and I guess I could do that by like cutting the pin of my thing here, it would power the TS100 fine. It would be a little bit it'd be slower to charge up, but it would power it fine at 15 volts. And I kind of think that that's a problem, right? Isn't, like, I guess you could add a jumper or something that you say to people, hey, if you're using a 45 watt iron, you can do whatever. In the Ralem firmware, you can select the source. Can you? I don't understand how the TS100 would be able to select the source. Yeah, so like, you could put a jumper on this IC, right, where you say, but that's probably for a minimum cutoff, I would say, rather than saying what it is, right? That like, if the voltage drops below this for a 4-cell battery, that, or 4S battery, that would be bad. Like, you can't go, hey, charger, I just want 15 volts or whatever. Yeah, it's overcurrent prevention or whatever. Yeah, so like, I think it's kind of a bad user experience to, like, a person has a power delivery capable power supply and this just doesn't work on it, because like, the power supply is capable of doing 20 volts and this is trying to draw more than that. But I'm not 100% sure if that is a big problem or not. Like, how common are power supplies that can't power it? Like, I bought a 45 watt power supply. It's downstairs at the moment, which is technically under spec, but it does work. It powers it fine. So yeah, I don't know. But one solution to the problem would be this guy, and we'll get into it in a second. Like, is it a bad experience to be like, okay, look at your charger, and if your charger does 12 volts, 1.5 amps, but doesn't do 20 volts, you can probably plug it in fine and it'll work. You know, as in, it'd be an incredibly long-winded story, right? So this, I'm still using the Amazon one here, powered on, doesn't work. I'm gonna swap out the Amazon charger for this U-green one. So this is an 18 watt charger, so the other one was 30 watt. And look what happens with this guy. This one, you'll see here, it's negotiated 12 volts, but it does work. Right? It's going to be slow, way slower than it works at 20 volts, but it does work. I don't think you can, like, can you watt limit on the Ralem firmware? I don't think the Ralem firmware would know exactly how much current is being used. Maybe. I don't know, actually, about the Ralem firmware. Like, it seems weird to me that, like, there'll just be some power supplies that don't work. So actually, I've never used the Ralm firmware. Is there a schematic for which, Pete? If you're talking about the TS100, if you search for Ralm TS100, yeah, but you see, the thing is with the power limiter, right? USB Type-C power delivery already supports that, right? So this guy supports uploading profiles to the board, right? So I can say profile, it starts from the highest number and works down. So profile 3, say that's 20 volts, 2.4 amps. And if my power supply can't support that, drop down to the next one. Now, I found out something about this chip this morning that is disappointing to me. So it supports 3 profiles, but profile 1 is locked to 5 volts. So ideally, what you'd want is it to go, hey, I want 20 volts or 2.4 amps or whatever it is, and the charger goes, I can't do that. And then it goes, okay, I want 15 volts at 2 amps or whatever the maths is for it. And the charger goes, I can't do that either. And then it goes, okay, can you do 12 volts at 1.5 amps? And the charger goes, yeah, sure, I can do that. And if it couldn't do any of them, it's just not going to work. It doesn't have, the power supply isn't capable of powering the TS100. But so I'd have to make a decision on, like, it should either be 20 volts. 20 volts is the obvious one. This is the ideal scenario where you've got 20 volts, 2.4 amps. That's what you want. That's golden. But then what do you put in profile 2? Do you put 12 volts so you kind of get as many other power supplies in as possible? Or do you do 15 volts because it's the next best thing? Yeah, so it's basically Ohm's law, right? Resistance is fixed. It's 8.5 ohms, and we're negotiating voltages either 20, 15, or 12. So the current changes based on that. Yeah, that is interesting, Colin, and that is something I want to test with this guy. So me and Colin have the same power bank, a 45 watt one, and when you plug it into the TS100 in this circumstance, it negotiates 20 volts, and it does more than 45 watts. So it's able to keep up with in reality, with the TS100. But will it fail negotiation? So who knows? So if you measure the voltage as well as the current, you know how much power is taken. Well, you know how much power it's going to take. I guess, maybe the Ralin firmware supports going, okay, never let this MOSFET be on 100% of the time. Limit it to be 70% or something. But that's bad user experience, right? It's like, hey, this will work with this power supply if you have the Ralin firmware installed and you custom do it so the MOSFET doesn't turn on all the time. That's just bad. I just want it to be something that you can plug this into your TS100 the same way as it's any power supply. It just works, right? So this is a valid use case for it, but this charger is its worst enemy, right? So this one, the IP2721, will go, hey, I want 20 volts. And if the charger says, I can't do 20 volts, it'll go, okay, give me 15. And if the charger goes, I can't do 15, it'll go, okay, give me 12. And it'll give 12, right? So the only thing IP2721 negotiates is voltage. Well, if people use a 5 watt supply, it's just not going to work, right? As in, you can say any power supply over 18 watts will work. Or, you know, as in, it wouldn't be a power delivery supply if it was that. But like, this is a power delivery supply, does 30 watts. It is capable of powering the TS100 at 15 volts. Like, if we do the maths of like 15 volts divided by 8.5, like it only needs 1.7 amps at 15, 1.75 amps at 15 volts. So this can power the TS100 at 15 volts. Or at worst case scenario, it could, well, it doesn't actually do 12 volts. That's interesting. So like this could power the TS100, but it can't power the TS100 using this. I have to cut the leg of the resistor. And maybe that's okay. I don't know. Like, as in, if you're using, like, I would really like it to be smart enough that it just does whatever. This one doesn't use a button. It uses profiles that you upload. So you upload a profile and say, hey, I want 20 volts, 2.4 amps or something. Yeah. So like there's other styles of these kind of chips. Like there's this one. Right, this is based on something else, but there's a button to change between the voltages. Seems to... I thought it went up to 20 volts, but maybe it doesn't. 12 volts seems to die. Oh, sorry, sure, the supply can't do more than 12 volts. Probably be the problem. So yeah, it does 5, 9, 20. "12 volts isn't in the current version of..." Oh, really? That's interesting. Like, I think you should just be able to say any 30 watt or higher power delivery supply will work. You could do a dip switch, yeah. But you kind of have to explain to people about, like, you know, this crack of, okay, you have to, if your 20 volt can't do 2.5 amps, then do whatever. I'm like, maybe that's fine. But then the other thing as well is the idea behind the Flexi Friend was to be able to, like, wrap it up, which you would not be able to do anymore if it needs to be user configurable. So what we'll do is we'll try this out. It's nearly 12 o'clock. That's fun. So this is taken, like, the default of this is saying, like, give me 20 volts at 1.5 amps. Yeah, we could make two versions. Yeah, you could do the minimum power supply. Yeah. Like, you kind of need a 50 watt or higher power supply to be sure. To be sure that it does actually work with it. It's funny that this doesn't say anything about power delivery, but it does work. Can you get your charger's max output through PD? Yes, you can. You can say, give me 20 volts, which is the highest power delivery does, and say, give me the max current you can give me. But that's not a concern for the TS100. Like a TS100 won't heat up any faster if you're plugged into a 100 watt supply over a 50 watt supply. 48 or 49 or whatever it is the max. Yeah, so like, do you do this one and just use a little bit of a switch? Maybe. Do you do this one with its profiles, does 20 volts, also does 15 volts, then says, you know, you don't work? Can you query? Yeah, you can, yep. So let's test that out. So this board is capable of querying. This board is not. This board, you can upload profiles and say, I think you do have some contact information. I'll send you some email. I have contact information of who? You can email me though, yeah. Or if you want to message me on Discord is a good place. It's part of the negotiation. Yeah, so it negotiates. It says, hey, can we do 20 volts at 2.5 amps or whatever it is? Sure. Yeah, can we do 20 volts at 2.5 amps? And the charger says no. Then you go, okay, I'll move on to 15. So this one is capable of that. This one is capable of saying, do you do 20 volts? Doesn't talk about amps whatsoever. All it knows about is the voltage, doesn't know the amps. Well, this knows about the amps too. So let's solder this up and see, can we test that out? I don't have... It's more flux. We may, do you know what as well? We'll solder it using my the thing we just made, so it can sign its own debt warrant. I can't remember which charger is which now. Should probably mark them. See you, Johnny. This is this has to be the 12-volt charger. It's so slow. Yep, it sure was. Right, so there's a few pads here that I'm just going to have to solder to because I don't see any other way of doing this. I'm stripping some wire at the moment. So you have a bit of peace in the house. Are schools open long? Unexpected Maker? Or Sion, I suppose. I don't know why I called you Unexpected Maker. I suppose that is kind of your name. Oh, right. This is obviously the first day that they're back. Yeah, that has to be a big relief. I have to be honest, sometimes I do find it stressful enough in the house. Like, as soon as I'm finished work, like I step outside the door here, like the office, and there's like just a queue of things for me to do or whatever. And or even like just daddy, I want this, 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 I want this. And it's just like, oh, can I get a second to breathe? So sorry, I'm just stripping wires here, and I am into repositioning the for that. Okay, so let's get a bit of blue tech going. Alright, so VBus, ground, SCL, and SDA. Now, I doubt schools won't open in Ireland again till September. Like, definitely not. Like, what's sorry? D&D thingy inside the heart. What's a D&D thingy? Do not disturb. Oh, no, I don't have that set up since I moved, actually. They're pretty good at, like, not coming into me in the office, but it's as soon as I step outside the office, that's when the fun begins. Like, I honestly, and this is no exaggeration, like, I considered bringing a packed lunch to my office, just because, like, as soon as even, like, lunchtime comes around, daddy, 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 and it's just like, ugh. Yeah, like, maybe that is the way to go. Just buy a 60-watt supply. The 60-watt power banks are rare, though. Like, and I think this is one of the huge advantages of this setup, is that, like, I can power my soldering iron from power bank now. Like, literally, I have a fully powered soldering iron from a power bank, which I think is pretty cool. I don't know what everybody else thinks about that, but I like it. This isn't the best soldering I've ever done. So I was saying, Pete, about the TS80P. The TS80P is on its way to me at the moment. I will be doing a review of it. It's not happy with whatever's going on at the moment. Oh, my resistor leg didn't last. The differences is literally the power delivery, as far as I know. It supports 12 volts, 2 point something amps. See you, Rory. Thanks for joining. So, like, the TS80 has a max max power of 18 watts. This will have a max power of 30 watts. So it's a fairly significant improvement in It's a fairly significant improvement on paper, but who knows how that will manifest itself. But it uses the same tips as far as I know. It looks like physically the same. I think it fans out a little bit more, but other than that, it looks pretty much the same. I feel like I cheated there. I just randomly tapped and it went in. I'm gonna not use this anymore because it's very fragile. Could do with a bit of glue or something. SCL. Yeah, the connector is great. I don't know if I mentioned it, or no, I definitely didn't mention. So I was buying the connector of Maker Fabs as well. Same kind of thing, that like I can find the connectors on AliExpress, but for a selling point of view, I do not like buying stuff off AliExpress, because like if you get 100 orders or whatever, and you just go buy 100 things on AliExpress, like they mightn't come for like 3 months. You know, you can't rely on that whatsoever. So yeah. The new IC has done nothing so far. Right, let's remember that blue is clock and white is data. Now I need Arduino Nano or something. Here, I have a Nano, and I even have some spare I2C pins, but maybe I'll just put it in a breadboard. So Maker Fabs solve that problem for me, because you can get them to source things for you. Like, another thing I'm getting them to source for me is these things, like the actual flexible cable thing. Like, I can buy these from AliExpress, but I have the same problem with them. Well, if I get it from Maker Fabs, they can ship it to me with the like assembled PCBs I get off them or whatever. So yeah. What are the SDA and SCL pins of a Nano? Yeah, so the other thing about that, Pete, is that so I want to get Maker Fabs to assemble them for me. So like, I want to say, hey, Maker Fabs, I want 30 of these, or whatever, 50 of them, or whatever it is. See you, Graham. Oh, jeez, I would not fancy a trip to IKEA at the moment. I think IKEA opened yesterday, or today actually, in Ireland. So yeah, zero crack. Okay, so this guy sells a thing on Tindie. Does he have it here? It was sold out the last I saw. So it's a breakout board based on this chip, the ST USB 4500. Think of hot dogs. hot dogs would be nice, but the nearest IKEA to me is also like an hour and a half away, so I'm fine for hot dogs. Analog 4 and 5. Cool, thank you. Yeah, so this guy has made this thing, and he also has a sketch to upload the profiles for it. So this is perfect for us. He's libs. Okay, it's just a soft wire. I don't know why he's using the soft wire. Why wouldn't he just use regular wire? Did you think of any reason why he'd use... Like, he even uses the correct pins. 4 and 5. Oh, wait, they're not 4 and 5. What did you say there? You said 4 and 5, didn't you? A4 and 5, yeah. So he uses the correct pins, but still uses the software I2C. Need not be the I2C. Maybe he's just doing that so you can use any pin you want. Doesn't make sense to me. I don't know. But anyways, he looks after all this stuff. Yeah, so maybe if I just refer to it as A4 and A5, is it? Yeah, sure, we'll just give it a go. Okay, so I need to open the Arduino IDE, you know. I'm just gonna just show me for a second, so I'm not sharing anything I don't want to share. Yeah, so the reason I was like, it's important to me to be able to source parts that maker fabs can source. So, like, I don't want to send them parts, right? I just want to say, here's my bomb, just go get it. So the IP2721 and this ST USB 4500, there's a significant price difference in them. Like, I think it's $1.50 more per unit. Oh, you've got the mother IKEA. Okay, so let's just go back to the screen share. So let's just go to the raw of this. Grab all of it. Here is a sketch. Just paste it all in there. Yeah, he's written it for software serial. Well, he just instantiates a wire, so I could just instantiate a wire. Right. Will we see, does that work? I actually forget. How do I instantiate a wire on a on a nano? Nano. Okay, let's give it out. Yeah, whatever. Examples, it would be wire, master, reader, writer. Yeah, it's a master reader. Let's just include wire and then wire.begin, right? So I'm just gonna get rid of that. I'm just gonna try wire in here, and we'll use A4 and A5. Okay, so which is which? Did someone mention? It's A4 and A5, but which is data and which is clock? A4 and A5. It's normally clock and data, right? So clock, I'm gonna say is A4. data A5. Somebody let me know if I'm doing that wrong. Black would be ground. And then you sound real boomy, do I? Okay, so that's that. Screen share. So I've got it plugged in. Data is 4 and clock is 5. Data is 4. Oh, I have it the wrong way around. I might just double check that. Yeah, I'll check. No problems. Arduino Nano I2C pins. SDA is A4 and clock is A5. So you are correct. Thank you. Okay, so now I need to find my micro USB cable. Ugh. Well, I guess maybe I need pull-ups or something, but maybe not either. Who knows? Okay, so going back to the sketch that I just did. Let me get rid of that so I can see screen share plus desk. Yeah. Right, so let's save this as ST USB 4500. Okay, so he has a ton of things up here. So he has 5 volts is whatever. So PDO count between 1 and 3. So I want to say 3. 20 volts, and then he wants PDO current of 5, is it? Yeah, so I don't need 5 amps, but I could do with 2.5 amps, right? So if we go back to my 20 volts divided by 8.5, which is the resistance, is 2.34. Okay, so we can negotiate this, 2.5. Right, and then 15 volts, let's do 15. So again, 15 divided by the resistance of the iron, which is 1.76. So I'll just do current 2. I think you can set more fine increments than that, but this will do for now. Okay, so I think we should just be able to upload this. Speed crunch, is that a different calculator? I don't know. I've never heard of it. Okay, so I'll just try upload this now. The other thing that I was thinking of as well is that the IP2721 version of the board is very focused on the TS100, Right, so I want a flash configuration. Flashing, hang on. It's very focused on the TS100, but if you made a board based on this, the ST USB 4500, it is potentially much better, or it could be used for anything if you allow the user to do whatever. Just follow the prompts. Surely it comes back. Flashing, hang on, like surely it would. Seems to be taking its time. I guess I did change the wire thing, but like I think it should be fine. So what's the first thing it printed? It printed something in sector, whatever that is. Flashing, hang on. So it hasn't failed flashing, but it hasn't verified. So it hasn't even got down to here. So it's whatever this is. Okay, so it's died out of this. Whatever happened. Maybe the old pull-ups couldn't hurt. Yeah, okay. I can just use 10Ks, right? I know you'd normally use 4.7s and stuff, but I have 10Ks here. So that is what I'll use. Okay, so I'm just putting in some 10K resistors. I don't know if I have any jumper wires here, so I'd have to actually make up a jumper wire. To power my 12 or 5 volts. I'm not bothering making up a jumper wire. I'm just gonna cut a leg off a. Just gonna cut a leg off a resistor. Oh no! Maybe that's what happened. Maybe it's not the pull-ups, it's the. Maybe it's the soldering. So we lost V-bus. V-bus, no. don't think I have enough solder on it. Just blob a bit on here. It's not superb, but it'll do. Okay. VBus probably is necessary, I would say. Alright. Let's just reset the nano. Okay, that's working here now. Flash the configuration. Okay, F. Flashing, hang on. I think it's a 5-volt nano. Pretty sure it is. Maybe I should just use his software serial. Yeah, yeah, he says you can power it from either 5 volts or 3.3 volts. Let's use his software serial thing. We're trying to upload new profiles to this board. So we can say, like, although you can do 20 volts, unless you can do 2.5 amps, that's not an acceptable voltage range for me. Like, it will fail negotiation based on both voltage and current. Just 1 second. Screen. Right, so I'm going to add zip to library, documents, downloads, recent items, streams, it's not streams, users, streams, that's the soft I2C. Yeah, where is this? Here. Where does he use the SDA pins? He defines them here. I don't know. Maybe that was overwriting it actually. Maybe that's why the wire wasn't working. Yeah, sure, look, I'll just use his thing. Especially now that I have it installed. Alright, so upload. He uses software serial, and I guess he uses it with hardware pins. That's unusual, right? Right, it didn't print the stuff up the top this time. Okay, well, it's working now. So all done. Right. Okay, so I need to connect some wires or something into. There we go. These will do the finest. I'm gonna plug that out from there. Hey, Mats. This one is easily available. So this is the ST. What is it? ST USB 4500, and it's available like Mouser, DigiKey, basically everywhere. And like this reference board that I'm using, where is it? That's supposed to be. This reference board that I'm using here is. Sure, I might as well plug this. Oh, do I want to plug it out fully? Is like also freely available, and they've the documentation for this board. Which is which? They don't have which is plus and which is minus. That's weird, isn't it? I presume it's ground up the top. That's a bit of an oversight. It is not. It's. Why wouldn't they put that on the board? Ground is the bottom one. Okay. Hey, it's only. What? Mats, what is your use case? Because I have been looking at a few of these now, so if I know your use case, I might be able to advise better. This is not going to work. I don't have a small enough screwdriver. It's a bloody flat-headed screwdriver, and it's quite small. I'm just yeah. I do not. I haven't looked into the innards of the TS100 much at all. I'm just gonna get a screwdriver. I'll be back in 2 minutes. I just need to go to my garage to get it. Yeah. Be back. I might wee as well, so maybe 5 minutes. Hello. I suppose I could have like kicked off an ad. Could I have? I don't enable ads on streams. Single board computer and extension board with power. So do you have like it would be a fixed power requirement, so? If this doesn't work, I don't know what. Okay, this one works. Yeah, so Matt's Aaron is correct. Yeah, that STB USB 4500. 96 boards has a standard. Some boards take 8 to 15 volts. Well, the power delivery you can only negotiate one at a time. Right. That's like it doesn't allow you to get multiple voltages all at once. That's understood, right? Yeah, like it'll heat up faster at 20 volts. But once you meet the requirement. So yeah, Matt's once you meet the requirement, you should be good. Okay, so what I have here is, I guess I'll use this thing too. Because why not? I suppose I only really needed to use this. I didn't need to measure the output at all. But so I have two wires connected to the output. I'm going to connect them to my multimeter. Alright, we are going to plug in. So we're going to plug in, this is my Mac charger. Should negotiate 20 volts, and it does. Okay, so that's good. I am going to plug in the Amazon charger. This should negotiate 15 volts because it should not be able to supply the current demands. Plug that in here. And it does. So that's good. And now if I plug it into the U-green one, which is only an 18 watt, it will actually fail. I think it's just a resistive load. It's a MOSFET controlled resistive load. So when it reaches temperature, so it only negotiated 5 there. So, well, I guess I can show on the output, but it doesn't really matter. Well, actually, this is interesting. The output is 0. I guess maybe it's because it failed to negotiate anything. Yeah, it's because it failed to negotiate, which is fine. Yeah, I think it is, right? It's just it won't power up at all if it doesn't meet the requirement. Yeah, so as far as I know, Pete, it's a resistive load controlled by a MOSFET. So when it reaches temperature, it stops. So yeah, this new one now, so it'll negotiate 20 volts where it can and drop to 15 volts if it can't. I guess the real test is my 45 watt power supply, which is downstairs. Let's just grab it. Back in another second. Okay, so here is my big beefy boy power supply. Which one is which? I really need to mark these cables on both ends. I put a bit of insulating tape or even a marker or something to do. So that's the 5 volt one. It's the 15 volt one. So now what will this negotiate? 15 volts. So this is interesting. So this is the power bank. It negotiates 15 volts because it says, hey, you're asking for 2.5 volts and I can't do it. But then if we plug that out and we plug in, so this is the IP2721 board. So it's getting 20 volts. When I power it on, oh, sorry, it's upside down, but like it does 2 point, well, maybe it maxed out, like there's 2.49. Like, so it can't, in theory, do 2.5 amps, but in practicality it can. So the IP2721 version would actually be better on for this power bank than the other one. So like I guess maybe I end up doing 2 versions, like I think that, but that's a bad user experience too. Like, which Flexi Friend do you have? Like, do you just have a Flexi Friend and Flexi Friend Plus or something? You're designing the whole schematic of the TS100, is it? Well, it does time out, the TS100. So, bit of thinking to do around this. Like, I think the ST USB 4500 is a good solution. I need to figure out how to set it more granularly. Like, maybe it's even covered in this thing. Because, like, I should set it to be exactly what it is. Like, I'm currently looking for 2.4 or 2.5 amps when I only really need to look for 2.35. The cost difference in the ICs is about $1.50 each. There's more parts required on the on the ST USB 4500 one. The other thing about the ST USB 4500 one is that I need to program it. Like, so what you seen me do just there, I need to do that for every chip before I send it out. Like, I have to program it to, like, maybe I change the variables a bit to get it proper. But, well, see, the define that he's using is like a lookup table or something. Like, you know, it's the number that's actually getting passed in here when I say 2.5 is this 9. Yeah, I suppose, like, ba, 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 ba. PDO voltage. Yeah, so I need to look up the data sheet to see what the story is with the current. Can you set ranges in the thresholds? Can we see? Well, the amp list is currently this one, but I just want to look up the ST USB 45. Well, I probably have it downloaded in my data sheets. What you do? It didn't make a whole lot of sense to me, the data sheet. Here it is, the I2C interface. User defined parameters. So I'm pretty sure he has a lookup table or something. Yeah, for flexible current value. I need to look into it a little bit more. Can you only set one flexible lookup? Or one flexible current value? Seems like that might be the case. Where is the configuration? I don't know, it has to be down here, right? I2C interface. Okay. So you can either set it to be 00B, which is flex, or you can set it to be one of the ones from the lookup. I don't understand. With a buck converter, you can dump 5 volts into your load. I don't. In what context, Pete? So it looks like you can do either one of the ones from the lookup, or you can do the flex one. So we could try programming it again with the flex one. To get a more accurate, so like 3.8. What did I say I needed? 2.35. So I'll say 2.36. 2.36. Oops. So I want this to be current flex now. PDO1's current. I don't want it to be current flex. I just want it to be, I don't know, current 1. It's not going to actually power the board anyways, so it's possible to ask for the max current, but it just doesn't matter. Like, as in, this isn't a negotiation to say, give me this much. It's, are you capable of giving me this much? Like, if your board, or if your power supply is capable of getting 5 amps, and your board is capable of receiving or using the 5 amps, even if you ask, like in the negotiation stage, for 2.5, that's just, hey, can you give at least 2.5 amps? And the power supply goes, yeah, can do that. And it will use the 5 amps. There's no problem. But you, like, so I'm not changing the TS100. The TS100 is staying the same. Like, you could configure something like the IP2721 or this to say, give me the lowest profile, right? As in, I don't want 20 volts, I just want 12 volts. But, like, people don't want their soldering iron to take, like, as in, I've tested like the difference between how long it takes to power the TS100 on, like, to get to temp on 24 volts versus 12 volts, and there's like a 40-second difference or something, and people don't want that. They want the fastest, like, as in the overall scheme of things, like 50 watts or whatever for the 10 seconds it takes to heat up is like nothing. Like, in terms of how much energy is being used in your house, it's nothing, right? So I guess it doesn't. I don't want to change the TS100. I am not touching the TS100. I'm just using. I just like the form factor of the TS100, and I just want to use that to. I just want to provide a different way of powering it. Come on, USB cable. Right, so I'm plugging back in my Nano. But like, this is the boost converter, right? Like, people have USB-C power delivery chargers. Like, my MacBook has one. Most new laptops have them. Like, my power bank has it. Like, that is the buck converter, right? Like, I just, I just wanted to be able to plug into these existing things people already have and just negotiate the correct voltage. Like, is it better if it does 24 volts? Yes, it is, but that's like more complicated, right? As in, we're just going to take the power delivery thing that people already have and just power it that way. I don't understand. Not if you can deliver 5 volts. In what context? Yeah, like I just want people to be able to use their existing USB-C power delivery power supplies, or if they want to buy a new one, that's fine too. Like, I would prefer, personally, like if I needed to get another power supply for my TS100, I would prefer to buy a USB-C charger than an actual barrel jack, right? Because I don't solder all the time, and having something that I could plug my phone into when I'm not soldering is really useful too. Okay, yeah. No, like, basically I just want to take 20 volts wherever possible. Uploading to I/O board. It seems to be taking its time. I'll just upload again. Well, I think what he was saying. Well, actually, I'm not sure. Like, it would just take way longer at. Well, it doesn't work at 5 volts. I don't know why it doesn't work below 12 volts, but it doesn't. Um, but. Yeah, like, I want it to be as fast as possible for people. Yeah, like the power delivery, you'll never get one that does that. Like, the max power delivery is like 5 amps. Or, yeah. Oops, I plugged this directly in rather than using my little connector thing. So I don't know what that negotiated. I suppose I should probably share my screen or my desktop too. Still negotiated 15 volts. This was me. Yeah, so it's still negotiated 15 volts. Now, I'm not 100% sure if what I did was correct, but like, even still, it should be out of spec, right? Like, 2.36, I think, is what I put in. Multiplied by 20 is 47 watts, and this power supply is 45 watt rated, so it probably is out of spec for it. Yes, at 5 volts, most of these chargers anyways. So like, here is a 61 watt charger, and at, where is it? At 5 volts it does 2.4 amps. 9 volts it does 3 amps, and at 20.3 volts it does 3 amps. So like that's still a 60 watt charger, but like when you use the 5 volt part of it, that's all it does. Like it only does 2.4. So I have another one here. No, that's not USB-C. This one. This is an 87 watt charger. Still only does 2.4 amps. 9 volts at 3 amps, or 4.3 amps at 20 volts. Yeah, that's the other thing. The cable can probably only do 5 amps, right? Yeah, okay, so something to think about. So I think the ST USB 4500 is the better option. It's more expensive, but like, you know, it won't be crazy more expensive overall. The fact that it negotiates the correct, like, you know, it won't, like, it didn't work with the 18 watt supply at all, while the IP2721 version did. But I'm less worried about it not working with the 18 watt one and working correctly with the 30 watt one, because the 18 watt one is not great. So yeah, it's more flexible. It is more work. Like, okay, the IC is €50 more. There's definitely going to be a cost associated with me programming them, right? I have to build a jig. I have to program each one. Yeah, I still have to build the bloody thing. that's another thing as well. So yeah, food for thought. Heat is nothing more than power, so you have to get it from either higher voltage or from the current if you're limited to the set amount of current. Oh, absolutely. Yeah, so I'm just going to use standard header pins. So like, the other thing I was thinking about doing was to make it more flexible for people. This is an Osh Park version of one of the early boards. So what I was thinking about doing was putting, maybe even putting pins here for the screw terminal. So you can have either your XT60 head or you use your screw terminal head instead. So like, you know, or maybe I just make two versions of the board. So that would be, you know, like usable. Actually, do you know what? It actually fits in. No, that's yeah. So like the way I had pads soldered to the bottom here. Yeah, but that involves like the user having to figure out which power supply he has and what they should set it to. And like, you don't know that it's capable of doing like a current sense resistor, like is in you don't know how capable the power supply is until it's overloaded, right? Uh, you know, like as in when you plug in the power supply, like it only gets overloaded when you turn on the thing, and then it turns off, then renegotiates the voltage. The IP2721 doesn't support that. It only negotiates the voltage once at startup. It doesn't let you change it on the fly. So people don't mind the regular one with a dip switch. That's good to know. Yeah, if I found a nice small little switch, maybe that would work out. Let's see what like that's getting really complicated. Like, as in, so you're having current sensing things to switch like resistors, transistors to switch resistors, but you're also cutting power to the IP2721. So, like, if you're going down that route, I think you should be using the ST USB. Like, I guess you don't have to program it. But yeah. Okay. Push button switches and relays. Switch. It's not really a dip switch, is it? Because I'm only changing one thing. Dip switches normally have two, right? Or do they? That's one. 34 cents each. There's a surface mounted one. They're quite expensive. Maybe I'm just looking in the wrong spot. Yeah. 12 cents each is not the end of the world. I think an SMD one would be better. It's black as well. Not recommended for new designs. No. There, that one is 40 cents each. Yeah, I also opened... I don't think they'll show up as toggle switches, will they? Oh, here you are. Yeah, like I've used those kind of side-mounted toggle switches before. Did I see one up here? Like this one. More as a power switch, but yeah, I'm pretty certain I'm not going to do the extra stuff, because like, how does it even work? Like, if the Mac charger doesn't negotiate power delivery, it doesn't output anything. So, like, when you turn off your IP2721, your Mac charger is liable to stop outputting anything. It has 3, but it's like 9 is no good to me. Is it 9? Well, 5 is the other one. So really it's only 2. Like it's 20 volts or 15 volts. Like 5 is no use. So like there's no point. So some form of a toggle switch. I'll have to find one at some stage. Switch height. No, it doesn't. Like that's a nice flat one. No, it doesn't, because you can buy like an adapter. I don't know where it is. I do have one, but so like say this adapter, right? This has a power delivery IC negotiating in it, but you can buy this kind of adapter that's just dumb, right? It just has a USB-C connector on one side, and connected to its VCC and ground is a barrel jack. And if I plug that into a regular like USB-A phone charger, it gets 5 volts out. But if I plug it into my Mac, it gets nothing out. What do I need from a toggle switch? Well, we're just looking at the possibility of... providing a toggle switch to switch between 20 volts and 15 volts. What happened, Ray? We're wondering about STB USB 4500 versus IP2721. The IP2721 is much simpler, but would require a user to... like maybe you just make both. Like as in literally, here's the smart one and here's the dumb one. There'd be no voltage or no current basically. So I need to add a 100k resistor between here, but like literally it would be just cutting this. It's just like a GPIO basically. But it's not the PSU's fault that it's not negotiating well. The PSU is a standard. It's us that's negotiating badly with it. You do need to reset the PD IC. You could add a solder pad. Yeah. But then it's not really like user configurable. Well, it is, but you can't like go, oh, I'm using my 15 volt. Maybe that's not a problem. Which is this IC, the IP2721? So the problem with the IP2721 is that if the power supply can output 20 volts, it will take 20 volts even when the 20 volts is not the most optimal solution for the TS100. Case in point, the 30 watt power supply from Amazon can do 20 volts but can't do the required 2.4 amps. So it just overcurrents. You can put in a switch and you'd knock it down to 15 volts. The user can manually change it to 15 volts and then it would work with the 30 watt power supply. the ST USB 4500 will take into consideration how much current you're able to provide at 20 volts, and if it can't provide enough, it will drop down to whatever else you configure it to be, so probably 15 volts. But that's not how power delivery works. Like IP2721 is saying to the thing, give me as much current as you can at 20 volts. And the power supply is like, cool, yeah, I can give you 20 volts, no problem. Like it's up to us to say what, like, can you match this current? But your soldering iron has no power to solder it. Yeah. The power supply is a spec, right? That's a standard and it's doing everything it should. Like, if we have a current requirement for 2.4 amps, we need to say it to the power supply, and we don't with the IP2721. Like, I'm not sure how else to explain it. The TS100 works on both, right? It has to have a certain voltage and it needs to match a certain current. Like, if you don't have those two things, it doesn't work. And the IP2721 only negotiates one of them. The current may be fine from your power supply. If it's over a certain wattage, it would be. The IP2721 isn't clever enough to go, hey, can you do 20 volts at this amps? No, okay, give me something better. Like, it'll just go, you can do 20 volts? Great, I don't even want to hear about your current. Just give me all you got. And then when you turn the iron on, it will overcurrent protect. Yes, like that's a concern, right? That, like, okay, my Amazon power supply overcurrent protects at 30 watts, but who's to say someone else's doesn't and catches fire? You know, that's not great. Like with the ST USB 4500, like, it's negotiating, like, it mightn't work. Like, it doesn't work with the 18 watt one, but it fails gracefully. The TS100 is no overcurrent protection. The TS100 is not being overcurrented, right? It is a load, like, is in the power supply is making available some amount of current. The TS100 requests, or like, uses 2.4 amps at 20 volts, or it doesn't, like, as in when it reaches temperature, it doesn't use that much anymore. So it's not being overcurrented. It's the power supply that can't provide enough, right? Ohm's law, 20 volts, 8.5 ohms, has to be 2.4 amps. And if the power supply can't provide it, it goes into overcurrent. Like, so my Amazon one does the overcurrent protection, but does everybody's? Possibly not. What happens then? So, like, if you fail gracefully, like, you go, okay, you can't do that. We can't negotiate at 20 volts. That's fine. You just move on. The power supply does. Which chip, Mohammed? The ST USB 4500 I bought off RS Components. But, like, it's available anywhere. And then the IP2721 I bought off Maker Fabs. They are an assembly. Well, they have a shop too. The IP2721 I bought off Maker Fabs. Well, the TS100 is 65 watts in ideal scenarios. So if you give it 24 volts, it's 65 watts. If you give it 20 volts, it's 447.2 watts. So yeah, if your power supply can't provide that, then it's basically just for an IO. It's literally like I need to add a 100k resistor between. Well, basically this needs to be connected to a 100k resistor and then to VCC, and like we want the possibility of cutting that, so it's no current whatsoever. Yeah, I think we'll call it a day at that. We'll fix up this one anyways, with the 100k resistor, and at the very least a solder pad. But like, Aaron makes a good point. Like, this is for your soldering iron. If your soldering iron isn't working with that power supply, what are you going to solder it with? It's hard to know. Tree jumpers, like as in physical ones, they're quite large. Is the only problem with them. Let's see what you're sending on. Oh, I have loads of them as well. Would people want side-mounted ones? I don't know. Yeah, you need 3 pins. Or like the last one doesn't need to be connected to anything. Yeah, like I use these on my Christmas trees, my panda boards, my... Should have used the 555. I've used them a lot. Yeah, but I don't think that's how power delivery works. You will lose the jumper. Like, they've negotiated that this transaction should be at 20 volts and then it goes down. So either one of two things happens. It either, well, 3 things. The voltage sags, whatever transformer in it blows because you're working it too hard. And there's my light gone. The battery in my light gone. Yeah, I don't think the side mounted is good either. You have to toggle inside. Like, have you seen how small this board is? There's no way you get the toggle inside. Yeah, I don't think the side mounted is the way to go. It's vertical standing up, right? Yeah. Although the last time I bought a really cheap button, it was like something like that is okay. It's a bit tall. Like, I'd prefer if it was like this. Like, that's awkward to press, which is fine. Yeah, like, why would you go with a jumper over a switch for something like this? Like, I use jumpers as switches on my matrix boards, but that's for current reasons. super small, like U shape. Oof. But like the TS100 can be powered with a dumb power supply. That's not what this is. This is specifically for USB-C power delivery. You could make an indent in the board, but I guess, like, why wouldn't you just go up? Build up to the sky. Do they have SMD surface mount, panel mount? Non-shorting. Like, that's a centimeter. I really need it to be... Can I get it slightly smaller? Oh, so you just have it side mounted, but not at an edge. That's even more awkward. But, yeah, maybe that's alright. Trim pot, it's too big. Well, I suppose they're not that big. Yeah, I suppose if you had the switch in, like, you'd have to use a screwdriver or something nearly to flick it in. Don't know. I'll have to make the PCB bigger. I think either way, like, I'd never fit it where it currently is. My thing fell off again. The ones that are used for stepper drivers are like potentiometers, though, right? Like, it's not a switch. Like, you'd have to twist it the entire way. Yeah. I think whatever I use, I'm probably going to need to make the PCB bigger. Unless I did a solder pad, but I don't like the idea of a solder pad. Jeez, that thing's tiny. What the hell is that? Do they have dimensions somewhere? Sure to do somewhere. Switch height. This is the smallest one they have, whatever it is. No, it's not the smallest one they have. This is really small. What's going on with him? Totally cute. Soft latch micro tactile. I don't like the tactile because you wouldn't know what it is unless you plugged it in. Route 1 with a resistor. Yeah. Yeah, it needs to be set before power up. Well, I guess, like, for the moment, I could just order a design with a 100k and you could take off the 100k and then it's floating, but I'd prefer to just order one last design. But anyways, it's 20 past 1. I need to go to bed. thank you all for joining in on the chat. I'll probably be dreaming about USB-C and switches this evening. Yeah, we'll see how it goes. We'll order something. Needs to be re-switched, which would be triggered by overcurrent. Perfect. Yeah. But we're still... I really need to think about this, because the IP2721, like, what happens in the overcurrent position? I don't know. So, good night, everybody. Take it easy, and I'll talk to you next time. Bye-bye.